Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. I'm so delighted today to have Dr. Harrison Schmitt. He's an Apollo 17 astronaut who was on the moon for 3 days, a former U.S. Senator. For more than 45 years, he's been involved in astronomy as an astronaut with NASA for 10 years, 20 years as a consultant and businessman and professor at the University of Wisconsin. He's a huge advocate of space-based private enterprise. He is looking to establish and make sure that a new and permanent era of human enterprise and settlement in space happens. He is the author of the book, Return to the Moon, Exploration, Enterprise, and Energy in the Human Settlement of Space. It gives me great pleasure to welcome you as our guest. We're delighted. None of us have met anybody who spent 3 days on the moon. Thank you, Harrison Schmitt, for joining us.
Great to be here. Thank you for the invitation.
Thank you, sir. First, I'd like you to share the emotionality, if you can go back to 1972, with your first impressions of going to the moon, being there, to just bring us in as an audience.
Well, if you are speaking of actually landing in the valley of Taurus-Littrow, once all of the technical and operational activities had been completed, and we were indeed able to first look through the windows of the Challenger, the lunar module, and then a couple hours later actually get out of the spacecraft onto the surface and begin to work, you could not help, at least I could not help, but be tremendously impressed by two things. One is the fact that we were there, and others had been there on the moon prior to us. And two, how magnificent this particular valley in which we landed was to the eye. We were in a valley deeper than the Grand Canyon. The mountains on either side went up to over 7,000 feet. And we were essentially in the narrowest part of the valley with only about 7 miles wide at the point where we were. So we had a view of these brilliantly illuminated mountain walls with their steep slopes from top to bottom, almost constant at 26 degrees. The sun was as bright as any New Mexico sun that I've ever seen, of course, with no atmosphere to attenuate its rays. But I think the hardest thing to get used to when you're there, and probably never get used to, is that the sky with a brilliant sun is black, absolute black. We're used to having a blue sky, as I see here in New Mexico today, and still trying to imagine what the mountains outside my window would look like with an absolute black sky is very difficult for the human mind to encompass, I think.
So you're literally in black and white for visual.
You are, and shades of gray, from blue to brown to light grays of various kinds. The pulverized surface of the moon is so finely pulverized that it, like any mineral or rock, when it's pulverized, turns to gray color with different shades. But still, everything's so brilliantly illuminated that it's quite a magnificent place to be.
It has been said that many astronauts who have been to the moon have a life change. There's something on a perspective level that, from an internal place, changes. Did you experience that at all?
Well, I don't think you would find many astronauts to say that. A couple might. But most of us, I think, just had an opportunity to be astronauts who went to the moon. And that changed the way people viewed our subsequent activities. Just about everybody that I know, in fact, I would say everybody that I know that's been to the moon is basically is the same type of person that I knew in the astronaut program.
Okay, got it. The capital investment you discussed in your book, Return to the Moon, at the time of your writing was less than $15 billion, or similar to the 1970s of a transatlantic pipeline in the 1980s for a Eurotunnel to bring a shuttle to the moon.
Trans-Alaskan pipeline.
Trans-Alaskan pipeline. Thank you, I stand corrected. Right now, do you think that number's different?
Oh, no, I think with the economy as it has been since then, the price of coal, although it went up significantly in, I believe, 07, 08, has come back down to about the $2.50 per million BTU that I use to calculate competitiveness. I think all of that has probably ended up with those estimates still being about right. Now, you've got to remember, this is an investor entrepreneurial effort and not a government effort. The government effort to do the same thing, if heaven forbid we let the government do it that way, would probably cost about 10 times what a private sector estimate effort would cost. Private entrepreneurial enterprises just do things differently. You have to think cost all the time, and unfortunately, we don't make our government think that.
I felt that your book was so detailed, it was like a galactic business plan for exploration, enterprise, and energy in the human settlement of space. That's how much detail it had in it.
Well, that was its intent, in part. I also intended to hope that most people could understand most of it. But also, it basically outlined all aspects of the kinds of things that a business plan to go back to the moon and harvest its energy resources would require.
Talk about helium-3. I had heard about helium-3 years ago, and I never had anybody verify that was one of the most useful and highly doable and important energy sources. And when you started to list all of them, from renewables to wind to hydrogen, I was very excited. But you talk about it. You're the one who had direct contact with it.
Well, the samples returned by Neil Armstrong and Buzz Aldrin on the Apollo 11 mission showed us that, as anticipated by 4 different teams of scientists, showed us that the soils of the moon contain solar wind gases, gases or atoms that have come from the solar wind as a result of the fusion processes that take place on the sun and in the sun. They had been collected on the moon over literally billions of years, and it was anticipated that they would be found in the samples, and indeed they were. One of those gases is helium, and an isotope, a light isotope of helium-4, which is what you normally get in your balloons, is helium-3, and there is it was discovered some 13 years later by a group of nuclear engineers at the University of Wisconsin under the leadership of Dean Kolsinski, that the concentrations that had been measured by these scientists in the Apollo 11 samples would be of economic interest if one could put together the overall enterprise necessary to collect it and bring that helium-3 back to Earth. It had long been known to physicists and engineers in that business that if you had helium-3 here on Earth, it would be a nearly ideal fuel for fusion power. Unfortunately, there's just not very much here, enough for various reasons that one can do research, but not enough that you could ever base a energy enterprise on its availability. And so they contacted me back in 1986 and asked me if I would act in a consulting capacity to the Wisconsin group and to try to understand better the nature of that resource, what we would call the economic geology of that resource, and begin to think in terms of just what would it take in order to bring helium-3 back to Earth and to design fusion reactors that could utilize it to produce electricity.